The overall goal of this procedure is to expand the accessibility and flexibility of robotic rodent neurosurgery by providing researchers with plans to build a flexible, inexpensive, and open-source robotic stereotaxic instrument, as well as the software necessary to design and share surgeries. This is accomplished by first machining and assembling a computer numeric-controlled stereotaxic instrument. The second step is to determine the scaling ratio of the stereotax by measuring the stereotaxic distance traveled per motor distance. A toolpath will be automatically generated from skull coordinates and will be exported to G-code. The final step is to test the surgeries using skulls of the animal species it is designed for. Surgeries should be modified according to the results of the test. Ultimately, the stereotaxic instrument can be used to quickly perform and share live rodent neurosurgery. Current applications include, but are not limited to, craniotomies, thin skull windows, and electrode or cannula lowering.
Robotic surgical instruments can increase the accuracy and replicability of rodent neurosurgery. However, commercial models can be prohibitively expensive. The following protocol provides plans to upgrade an existing stereotax to a motorized stereotax. G-code, used to control the motors, is open source and may be modified to meet surgeons' highly specific needs.
The included MATLAB scripts will help early adopters to automatically generate surgeries using simple point-and-click menus. While only a few generated surgeries are currently supported, the robot may perform the vast majority of neurosurgery techniques used in animal models.